Hi, my name is Tony Smith, and you're listening to my ENC2135 Project 3. The topic of climate change is kind of a no-brainer to me as an environmental science major. I was prompted to pick this topic because I remembered a simple instance where a family friend of mine came to me, asked me what my major was. To her, I responded, environmental science. She told me to go to college for a year, come back, and tell her if I still believed in this climate change nonsense. I was pretty baffled by the fact that someone could not believe in climate change, giving the unrefutable evidence that there is against it. So for this project, I look forward to debunking whether or not climate change, global warming, is a hoax, and I look forward to defending my position and also addressing the opinions of my opponents. So sit back, relax, and enjoy. I'm reading from a script, so if you see me looking around or looking over, it's because of the script. So let's just jump right into it. So there are a few kind of key questions, definitions, and differences I would like to address before I just jump right into my position. So the first one would be, what is the difference between weather and climate? This is something that most people do not know, as they kind of just look at the category as one lump sum and all lumped together. So weather can be defined as a short-term change in variables like temperature, clouds, precipitation, humidity, wind speed, and climate can be the long-term change in the weather. So it's long-term, it's average, and so what's important to keep in mind is that weather is short-term, climate is long-term, and average. So they're kind of related, if you would like to say that. The difference between global warming and climate change. Global warming is a term that can be used to describe a long-term increase in the average temperature of Earth, whereas climate change would be the long-term change in Earth's climate or the climate of a particular region or city. The term climate change can refer to cooling and warming alike, whereas global warming can only refer to the warming trend in Earth. How is the climate modeled, and what's the future for Earth? So, scientists at NASA and other organizations use climate models to foresee how climate on Earth will change. These models are basically computer programs chock full of mathematical equations, and these programs not only model Earth's future climate, but they can also go back and look at the past, which is actually pretty important because looking at the past and studying what's happened back then helps us to better predict what will happen in the future. So right now, there is pretty much a heating trend in the Earth's climate. So what we'll be seeing is that the Earth will continue to get warmer, the climate will get warmer, there will be more extreme weather. That's what meteorologists, scientists, climatologists, and everyone are starting to see. It is predicted that Earth's average temperature will keep rising over the next 100 years, although there may be some years where the climate is cooler or actually pretty steady. So that's as told by NASA. So don't just be quick to throw out the idea just because of a steady climate or one that has cooled. Other instruments that can be used to predict this kind of trend or change are satellites. These satellites can be used to view Earth in its totality, which gives a better view to meteorologists and climatologists. And there are other satellites that can be used to observe the sun and the output energy that comes from it, which is important to us on Earth. These reports can be used together to help scientists paint a better picture. Now, what is the cause of this overall global warming and climate changing trend? As stated by scientists at NASA, it can be noted that some of the causes of climate change can be natural, such as changes in the orbit of Earth, changes in the sun's output energy, and even some instances like volcanic eruptions that can put a lot of material into the atmosphere and cause a cooling. So there's that. But what we are really concerned about is the human factors that go into this problem. Many scientists believe and can show valued proof that humans play a very important part in the greenhouse effect, which in turn acts as a catalyst for the heating of Earth. Now, what is this greenhouse effect? The process is called the greenhouse effect because it is kind of relating Earth to a greenhouse. So what happens in greenhouse science is UV radiation or ultraviolet radiation passes through the glass walls of the greenhouse. And what accompanies the ultraviolet radiation is infrared radiation. And this infrared radiation is what we experience on Earth as heat. So the UV radiation easily passes through the glass walls of the greenhouse. But the infrared radiation has a harder time and can become trapped, and it causes heat, which is absorbed by the plants and creates a nice humid, hot, warm climate for these plants to grow. And our Earth and our atmosphere works in a similar way. So basically, to put it in terms of the atmosphere, ultraviolet radiation from the sun easily passes down to us through the ozone layer, all the layers of the atmosphere, whereas the infrared radiation has a harder time passing through. It gets a little caught up and it mixes in with the atmosphere and traps in a bit more heat. But what's happening is that there are some gases that are up in our atmosphere that are being released through processes that come from humans that really make the infrared radiation get further trapped and cause an increased warming. So, Michael Daly, a professor of environmental science at LaSalle College, says that gas molecules that absorb thermal infrared radiation are significant enough in quantity can change the climate system. These gases are called greenhouse gases. Daly continues to explain that these gases get mixed in the atmosphere, like I said, and further trap the infrared radiation, making it harder to escape, which in turn warms the Earth just like a greenhouse. Okay. So there's a list of common greenhouse gases that comes from the United States Environmental Protection Agency, or EPA. So carbon dioxide, which you guys may know as kind of one of the most important ones, is CO2, and it comes from the burning of fossil fuels, waste, trees, and wood products, and even the manufacture of cement. CO2 is removed from the atmosphere by the absorption from plants through the process of photosynthesis. There's methane, which is CH4, that comes from the production of and transport of coal, natural gas, and oil, and can also come from livestock and agriculture. I'm not sure if some of you guys have heard about how cows release methane from their excretions, bodily excretions, which is why it can be seen that it comes from a variety of agricultural places. So there's also nitrous oxide, which is N2O, that can be emitted from both agricultural and industrial practices and the combustion of fossil fuels. Fluorinated gases, so these are synthetic, but they are really potent and really powerful. So these are things like hydrofluorocarbons, perfluorocarbons, sulfur hexafluoride, nitrogen trifluoride. So like I said, they're all synthetic, but really powerful, really potent. They can come from a plethora of sources and industrial activities. These substances can be seen to deplete ozone, and these gases come in smaller doses, but like I said, very concentrated, very potent, so they do a heck of a job. And these are really the ones to watch. So, and another one that most people do not think of is water vapor. Water vapor can exist in the atmosphere at around 4% in any given location. So it kind of helps act as a catalyst as well. But like I said, water vapor is always going to be there. It's not really human factors into that one. But it can be also seen as a greenhouse gas. Some of the gases are more effective than others at enhancing this effect. And each gas can remain in the atmosphere for a different amount of time, from a few years to a few thousand years. So it really just depends. And what's also seen is that these gases just, I really do remember, you guys. Okay, so some of the consequences of global warming. I've compiled, a list from various sources that showcase the effect of this heating trend. They are just a small fraction of the things that can happen and that are happening right now. So the first source of incidents comes from a Rolling Stone article titled "The Point of No Return: Climate Change Nightmares Are Already Here" by Eric Hoax, who is a meteorologist. In the beginning of the article, he names instances right off the bat, like record-setting heat waves killing thousands of people in Pakistan and India, the rainforest in Washington's Olympic Park catching on fire for the first time in recorded memory, and London reached 98 degrees Fahrenheit, which is very unusual because that is the hottest day ever recorded there. And a popular live blog had to be paused due to their computer servers overheating. California is suffering from, the worst droughts in centuries and extreme weather patterns like very intense summer rain, which we are not used to. To boost his credibility, Hoax adds in reports from NASA climatologists James Hansen and Eric Rigneau. Hansen believes that if emissions are not reduced, then global warming is something that can threaten the fabric of humanity. It's really important. Rigneau and Hansen both have reports stating that parts of the ocean where ice is melting really fast are in a way cooling and slowing down ocean circulation, which is really important because this circulation is what kind of helps to keep a climate equilibrium around the world, which I will touch later on. Expert climatologist Michael Mann says this is yet another example where observations suggest that climate model predictions may be too conservative when it comes to the pace at which certain aspects of climate change are happening. Hoax further explains that the Pacific temperatures are at a high and are continuing to impact marine life. Rising temperatures can lead to ocean acidification, which is really bad for the reef communities that are teeming with life, and acidification just comes from an excess of CO2 in the water, which should not be there. So this causes coral bleaching and really just does a number on the coral reef systems and the coral reef communities. James Berry of the Monterey Bay Aquarium research team says, I used to think it was hard to make things in the ocean go extinct, but this change we're seeing right now is happening is almost instantaneous. And that is as reported by Eric Hoax of Rolling Stone. Research put out by scientists Stefan Ramstorff, Michael Mann, Jason Box et al. Is probably the most alarming. So this is again what I touched on earlier about the slowdown of the ocean circulation. So to keep a temperature equilibrium around the world, the circulation is slowing down, which is not a good thing. The scientists were able to report a temperature map that shows temperature trends over the 20th century that shows a cooling in the northern Atlantic. And what they're thinking is that this cooling is coming from the melting of the Greenland ice sheet, and this change has been noticeable from the 1970s to present day. And these studies are based on, sea surface temperatures, hemispheric temperature differences, and coral-based proxies. It has been proven that the further melting of the Greenland ice sheet will only contribute to the weakening of the circulation of the Atlantic meridional overturning circulation. So I wanted to add this because I first learned about this in the class that I am required to take for my major, which is OCE 4008 with Dr. Olivia Mason. That's where I first learned about it, and it's very alarming. So this is a part of physical oceanography, but yeah, so keep that in mind. Very alarming that this temperature equilibrium is kind of slowing down, and that does not look good for the future. In coherence with the talk of the sea, Chris Mooney from the Washington Post elaborates on the possible melting of the Totten Glacier in East Antarctica. The glacier covers an area of 90 by 22 miles. It has been noticed that it is losing an amount of ice equivalent to 100 times the volume of the Sydney Harbor every year. This is scary because if the melting continues at this rate, sea levels can rise up to 11 feet. Yes, 11 feet. Waters beneath the glacier are pretty warm, and that causes a more rapid loss of ice. So, researchers have taken gravitational measurements, radar, and laser altimetries to see what's happening below the ice, and it was seen that there are canyons under the sheet that make it more vulnerable to warm water. So the warmer the water, this warm water input is just causing a further loss of ice. And what's more alarming is the fact that this is not the only glacier that's melting. So if this one glacier can cause sea level rises of up to 11 feet, then adding in the rest, that just means that coastal communities are in trouble, which is where some of the highest populations are. On the more human consequence side, findings published by Joseph Schmiderber and Francis Tubiello are showing the impacts of climate change on global food supply. So the thing to look at is the fact that if trends continue how they are, nearly 170 million more people are at risk of hunger by 2080. And this can be caused by too high temperatures, poor soil, deforestation, etc., etc. And that is if we keep growing at the rate that we are growing, and that is if we can even sustain until 2080. How are we as humans adapting to this climate change as a whole? This is answered by scientists Leah Baring Ford, James D. Ford, and Jacqueline Patterson from a peer-reviewed source called Are We Adapting to Climate Change? They begin by explaining how they came to their findings. They developed a certain type of methodology which allowed for them to take adaptive actions. They explained that understanding the adaptations of certain places is incomplete due to the magnitude of the problem. The main finding, which holds the most support, is the fact that the way in which people adapt to climate change is almost entirely based on socioeconomic status. With that being said, this is bad news given that not everyone is on the same level and not everyone has the same resources. So, countries that harbor big, nice infrastructure and resources are kind of, at the forefront. They are above it, but the countries that cannot afford these things, they are the ones that are more at risk of experiencing the consequences and the just everything bad that comes with this global warming trend. It's kind of painted out for climate change to be more of a problem for those who are less fortunate, but we have to think that this is a global issue and these are people. So it all comes down to what you think is ethical and just saving the world that we live in. So there's some counter arguments. This would not be a fair argument if I did not address the opinions of those who are on the opposing side. So a website called Skeptical Science put together a list of popular arguments from naysayers, and I figured I would pick a couple that have the most standing and just kind of go from there. So the first is that human CO2 is a tiny percent of CO2 emissions. This is not true because of the simple fact that humans, we're just so industrialized and we're just in like this big technological age, and it's hard for the world to keep up with how we're trying to expand and how we're trying to grow and what we're trying to produce and make available to people. And these factories put out so much CO2 in cars and everything, just so much CO2 that you just can't you just can't ignore it. And this can be seen from reports that are stating basically CO2 emissions have increased since the dawn of the industrial age. So the proof is in the pudding with that one. It warmed just as fast in 1860 through 1880 and 1910 through 1940. Like I said, there will be some years where they're kind of anomalies to what's going on. So if the year's colder, if the year's steady, things like that happen. But overall, it can be seen that this is a warming trend. And you have to think about things that were taking place during this time. And people are saying that it's El Nino that's causing this trend, but El Nino has no trend. And El Nino is basically kind of the warming of the ocean waters, which, it happens, but it has no trend, so it can't be related to what's going on. I would like to begin my conclusion by stating a few ways in which we as humans can kind of limit our effects on the Earth. This list is from Melissa Dinchek of the NRDC, or the National Resources Defense Council. Okay, so we can reduce the way that we use water. It takes tons of energy to treat, heat, and pump our water. So also, don't waste food and eat a little bit less meat. 10% of the energy in the U.S. goes to growing, processing, packaging, and shipping food, and 40% of that food ends up thrown away into a landfill, only to release methane and also just take up space. And you have to think most of these things are plastic, which is not biodegradable, which is not good for the environment. Don't leave devices plugged in, waste of electricity, waste of energy. Shrink the amount of carbon that we use. Carpool to reduce those hydrofluorocarbons and whatnot being released into the atmosphere. Weatherize your home, so this will be good for you for saving money and also reducing your carbon footprint. And speak up. Talk to your friends and family about having good energy decisions and protecting the earth. For people to believe in climate change, not believe in climate change, this is a big slap in the face to the earth. The evidence is so overwhelming, and it's time for us to stop talking about the problem and acting on it. Even if climate change weren't real, why should we mistreat and soil our only home? The time is now, and the problems are here, and the ball is really in our court, so it really just depends on what we do. And if we're going to keep expanding this human race and human population, there's just certain sacrifices that we're going to have to make if we want to be able to actually sustain life and a healthy life. So really it's up to you and how you want to interpret the news, but all the evidence is overwhelming. And again, I only covered a small fraction of what they're finding, so educate yourself.